Venus is the second planet from the Sun and the closest planetary neighbor to Earth. It is the third brightest object in the sky after the Sun and Moon. Unlike most planets, Venus rotates slowly in the opposite direction. Structurally and in size, Venus is similar to Earth, often dubbed Earth's evil twin. Its dense atmosphere making it the hottest planet in the solar system, with surface temperatures high enough to melt lead. Beneath its thick, persistent clouds, Venus' surface features volcanoes and deformed mountains. Venus is named after the Roman goddess of love and beauty, known as Aphrodite to the Greeks. Most features on Venus are named after women, making it the only planet named after a female deity. Approximately 30 miles above Venus' surface, temperatures range between 30 to 70 Celsius, suitable for certain Earth-like microbes. At this altitude, the atmospheric pressure is similar to Earth's surface pressure. Venus cloud tops are whipped around by winds reaching up to 224 miles per hour, showing dark streaks that scientists have yet to fully understand. These streaks, which absorb ultraviolet radiation, may be composed of fine particles, ice crystals, or iron chloride. Another hypothesis is that these streaks could be microbial life forms protected by sulfur atom rings that shield them from sulfuric acid and ultraviolet light. Some Russian Venera probes detected micron-sized particles in Venus' lower atmosphere, like Earth bacteria. While these findings don't confirm life, they raise intriguing questions that warrant further exploration of Venus. Venus orbits the Sun at an average distance of 67 million miles, or 0.72 astronomical units. Light from the Sun takes about 6 minutes to reach Venus. Venus is nearly as large as Earth, with an equatorial diameter of about 7,521 miles, compared to Earth's 7,926 miles. As the brightest object in the night sky after the Moon, Venus held great significance for ancient cultures, which viewed it as both a morning star and an evening star due to its orbit's proximity to the Sun. At its closest, Venus is about 24 million miles from Earth. Venus also displays phases similar to the Moon when viewed through binoculars or a telescope, completing a full cycle in 584 days, unlike the Moon's 29.5-day cycle. Experiencing a day on Venus would be disorienting due to its extreme conditions and slow rotation, resulting in a day lasting 243 Earth days, longer than its 225 Earth day year. The Sun rises in the west and sets in the east on Venus. Its slight axial tilt of 3 degrees means it doesn't experience seasons like Earth does. Venus has no moon but has a quasi-satellite named Zuzi V, discovered on November 11, 2002, by Brian Skiff at the Lowell Observatory. Quasi-satellites are asteroids that orbit the Sun while staying close to a planet. Zuzi V, ranging in size from 200 to 500 meters, orbits near Earth but poses no threat. It will come closest to Earth in 2149, at about 2.2 million miles away. The name Zuzi V originated from a child's poster of the solar system, where 2002 VE68 was misread as Zuzi V. This name was officially approved by the International Astronomical Union in February 2024. Venus has no rings. Understanding Venus can shed light on how habitable planets form and evolve. Despite their similar beginnings, Venus became an inferno while Earth hosts abundant life. The study of Venus formation and history could enhance our knowledge of planet formation in our solar system and beyond. If sliced in half, Venus and Earth would appear remarkably similar, with iron cores, hot rock mantles, and thin, rocky crusts. Both planets have experienced volcanic activity and surface reshaping, with Venus potentially undergoing subduction, a key process in plate tectonics. NASA's Magellan spacecraft, which mapped Venus using radar, revealed a young, volcanically active surface with mountain chains. Soviet Venera probes captured images of Venus' rocky landscape before succumbing to the planet's harsh conditions. Volcanoes and tectonic forces have erased much of Venus' early surface, with newer models suggesting resurfacing occurred over an extended period. Venus' surface includes highlands like Ishtar Terra and Aphrodite Terra, volcanic craters, and unique features such as pancake domes and tesserae. Venus' extreme atmosphere, primarily composed of carbon dioxide with sulfuric acid clouds, creates the hottest surface temperatures in the solar system. Despite its similarities to Earth, Venus lacks an internally generated magnetic field. Instead, it has an induced magnetic field created by the interaction between the Sun's magnetic field and Venus' ionosphere. Venus may offer insights into the conditions necessary for life, both on Earth and other planets. Studying Venus' divergent path in habitability can help us understand what makes a planet suitable for life. Despite its harsh surface, the upper atmosphere's conditions hint at the possibility of microbial life. Earth, our home planet, is the third planet from the Sun and the fifth largest in the solar system. Despite being the fifth largest, it is the biggest of the terrestrial planets and the only known world with liquid water on its surface. Earth is slightly larger than Venus, with an equatorial diameter of 7,926 miles, 12,760 kilometers. Its name, taken from Old English and Germanic, means the ground. Key features of Earth. Earth is unique in having vast oceans that cover about 70% of its surface. These oceans have been crucial for the development and sustenance of life, providing a habitat for life to begin around 3.8 billion years ago. Atmosphere, composed of 78% nitrogen, 21% oxygen, and 1% other gases, Earth's atmosphere is perfect for life as we know it. It protects us from harmful solar radiation and meteorites, most of which burn up before reaching the surface. Seasons and climate. Earth's axis is tilted at 23.4 degrees, which causes the seasonal changes as it orbits the Sun. This tilt results in varying solar heating across the planet, creating different climates and seasons. Rotation and orbit. Earth completes one rotation every 23.9 hours and one orbit around the Sun every 365.25 days. The extra quarter day is accounted for by adding a leap day every 4 years. The Moon. Earth has one natural satellite, the Moon, which stabilizes the planet's wobble and contributes to a stable climate. The Moon formed from debris after a collision with a Mars-sized body billions of years ago. Geology. Earth has a dynamic surface with mountains, valleys, canyons, plains, and volcanoes. Its crust and upper mantle are divided into tectonic plates that move, causing earthquakes and volcanic activity. Magnetic field. Generated by the movement of molten nickel iron in its outer core, Earth's magnetic field protects us from solar wind and cosmic radiation. It causes auroras and affects compass directions. History and formation. Earth formed about 4.5 billion years ago from gas and dust. It has a layered structure with an inner core, outer core, mantle, and crust. The inner core is solid iron nickel, the outer core is molten, and the mantle is a viscous layer of molten rock. Size and composition. Both Earth and Venus have similar sizes and structures, with iron cores, mantles, and crusts. However, Earth is slightly larger and has a more dynamic surface due to active tectonics and a water-rich environment. Atmosphere. Venus has a thick, carbon dioxide-rich atmosphere with sulfuric acid clouds, leading to extreme greenhouse effects and surface temperatures hot enough to melt lead. Earth's atmosphere supports life and regulates temperatures. Rotation. Venus rotates very slowly and in the opposite direction to most planets, including Earth. A day on Venus is longer than its year, while Earth's rotation and orbit are more balanced. Magnetic field. Unlike Earth, Venus does not have a significant magnetic field. Instead, it has an induced magnetic field created by interactions with the solar wind. Exploration and observation. Space missions. Many spacecraft have studied Earth from orbit, observing its atmosphere, oceans, glaciers, and geology. Understanding Earth helps scientists learn about climate change, natural disasters, and the potential for life on other planets. Impact on life. Earth's stable climate, liquid water, and protective atmosphere make it a unique and hospitable planet for life. Studying Earth and its processes provides insights into the conditions necessary for life elsewhere in the universe. By understanding Earth's features and comparing them with those of Venus, scientists gain valuable insights into planetary formation, climate, and the potential for life beyond our planet. This photo taken by NASA's Curiosity rover shows Earth as seen from the surface of Mars, shining brightly in the Martian night sky, outshining any star. In this image, Earth appears as a bright point of light slightly left of center, with our moon visible just below it. The Curiosity rover, which landed on Mars on August 6, 2013, is the most advanced rover sent to Mars, dedicated to studying the planet's geology and searching for signs of past microbial life. The image was captured using Curiosity's Mastcam about 80 minutes after sunset on the 529th Martian day, Sol, of the rover's mission on January 31, 2014. An observer with normal vision standing on Mars could see Earth and the Moon as two distinct, bright evening stars. At the time the photo was taken, Earth was approximately 99 million miles, 160 million kilometers, away from Mars. Mars, the fourth planet from the Sun, is a cold, dusty desert world with a very thin atmosphere. Known as the Red Planet, due to the iron minerals in its soil that oxidize and give it a reddish appearance, Mars has been extensively explored, with rovers sent to roam its surface. Evidence suggests that Mars was much wetter and warmer billions of years ago. Mars has a thin atmosphere composed mainly of carbon dioxide, nitrogen, and argon. This sparse atmosphere results in a hazy, red sky due to suspended dust. The surface of Mars, with its iron-rich soil, appears reddish from a distance but also features brown, gold, and tanned hues. While current conditions on Mars are inhospitable for life as we know it, scientists are searching for signs of past life when the planet had a thicker atmosphere and liquid water. Mars has a radius of 2,106 miles, 3,390 kilometers, making it about half the size of Earth. It is located 1.5 astronomical units from the Sun, which is 142 million miles, 228 million kilometers. Sunlight takes 13 minutes to reach Mars. A day on Mars, called a sol, lasts 24.6 hours, similar to an Earth day. Mars takes 687 Earth days to complete one orbit around the Sun. Its axial tilt of 25 degrees causes seasons similar to Earth's, but they last longer due to its elongated orbit. Mars has two small moons, Phobos and Deimos, possibly captured asteroids. Phobos, the larger moon, is heavily cratered and gradually moving closer to Mars, potentially crashing into the planet or breaking apart in 50 million years. Deimos is smaller, smoother, and orbits farther from Mars. Mars has a central core, a rocky mantle, and a solid crust. The core is composed of iron, nickel, and sulfur, surrounded by a thick mantle and a crust rich in iron, magnesium, aluminum, calcium, and potassium. The planet's surface features volcanoes, impact craters, and the largest volcano in the solar system, Olympus Mons, which is 3 times taller than Mount Everest. Ancient Mars had river valleys, deltas, and lake beds, indicating a wetter past. Today, Water exists in the form of ice just below the surface in the polar regions and as briny water that seasonally flows down some hillsides and crater walls. Mars has extreme temperatures ranging from 70 degrees Fahrenheit, 20 degrees Celsius, to minus 225 degrees Fahrenheit, minus 153 degrees Celsius. Its thin atmosphere allows heat to escape easily, creating significant temperature variations. Dust storms can cover the entire planet, taking months for the dust to settle. Mars lacks a global magnetic field today, but certain areas of its crust are highly magnetized, indicating remnants of a magnetic field from 4 billion years ago. Numerous missions have explored Mars, including rovers like Curiosity and Perseverance, which study the planet's geology and search for signs of past life. These missions have provided valuable data on Mars' climate, atmosphere, and potential for sustaining life. Ongoing and future missions aim to further understand Mars' habitability, geological history, and potential for human exploration. By studying Mars, scientists hope to gain insights into the planet's history, climate, and potential for life, offering valuable comparisons to Earth and enhancing our understanding of the solar system.